Assalamualaikum. My name is Muhammad Surahman bin Muhammad Izzah. I will present for the abstract part. In this paper, mainly targeting and summarizing the topic about the fundamental of milling process by referring to certain journals from the year 2017 onwards. Milling, one of the metal machining processes. The title of this group assignment is chosen after referring lecture notes and some research on the journals that is available. Principle of milling covers a large collection of manufacturing processes designed to remove unwanted material, usually in the form of a workpiece. A variable in direction of tools axis angle. There are two types of milling process, which is plane milling and face milling. As for plane milling, the process of milling flat surface with milling cutter axis parallel to the surface being milled. While for the face milling, it is the milling of perpendicular to the cutter axis surface. Face milling flat surface and machines work to the length required. In general, parameter selection is based on the experience, taking into account the shape of the workpiece, technological needs, and the capability of the machine, the cutting tools, and the workpiece material. The keyword for this paper is milling, metal machining, plane milling, face milling, and parameter.
Assalamualaikum and hi, my name is Muhammad Yusuf Yaakoobs. We are from group number 4 for manufacturing technology section 1. And for today's, our group project is about machining process. As we know, machining is a modeling and producing process that remove undesirable material from a bigger piece of material to obtain the desired shapes. And there are several types of machining process, which are turning, drilling, and milling. But for our group, we have choose milling. And as we know, milling is used to remove the piece of metal to achieve the desired shapes. This process need the moving of tools such as linear or rotation to let the metal can be removed. And each of the machining process we have various types of cutting tool because some of the cutting will suit to certain shape only. So that's it for introduction.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Kamal Arif bin Amir. My metric number is AD190021. So I'm going to start with literature review. Types of milling operations. Plane milling. Plane milling is typically accomplished with the workpiece surface parallel to the surface of the milling machine table and the milling cutter position on a normal milling machine arbor. Between the milling machine spindle and one or more arbor supports, the arbor is well of support in a horizontal plane. For simple milling, the workpiece is usually attached directly to the table or support in a vise. If the workpiece surface to be milled is at an angle to the base plane, it should be held in a universal vise or on an adjustable angle plate. Next, for face milling. Face milling is the milling of perpendicular to the cutter axis surface. Face milling creates flat surfaces and machines work to the length required. The feed in face milling might be horizontal or vertical. In face milling, the teeth on the cutter's periphery do almost all of the cutting. When the cutter is properly ground, the face teeth actually remove a little amount of stock that is left as a result of the workpiece or cutter springing, resulting in a finer finish. To facilitate handling and clamping procedures, large surfaces are typically face milled on a vertical milling machine with the workpiece attached directly to the milling machine table. Next is optimization of milling operation. In general, parameter selection is based on experience, taking into account the shape of the workpiece, technological needs, and the capability of a machine, the cutting tool, and the workpiece material. The most important factors influencing the surfaces of a machine process are the depth of cut, fade rate, and cutting speed. Because milling has a more complex cutting mechanism than turning, Progress in building constraint optimization system for milling operation has been ever slower than for turning operation. The ideal number of passes is first calculated using dynamic programming, and then the optimal values of the cutting parameters are discovered using a nonlinear programming technique called geometric programming and the objective function highest production rate.
For methodology, the process of metal machining can be classified into a few methods or unique techniques to perform a certain output process. For this paper, it is chosen that the process of for metal forming will be the milling process. As for the milling process, it can be carried out by using plane milling and face milling. To cut a plane a straight surface, different cutting edge tools are rotated over the work. The subjector will describe and list out all the processes that have been successfully accomplished through the research that has been done by past researchers.
Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif bin Saluddin. I will continue for theoretical milling machining. So, for the introduction, milling machine is type of machine which is it removes the material from workpiece by feeding the workpiece a rotating multi-point cutter. The metal removal rate is higher, very high as the cutter has a high speed and many cutting edges. It is the most important machine in tool room as nearly all the operation can be performed on it with high accuracy. Working principle. The workpiece is holding on the work table of the machine. The table movement controls the feet of workpiece against the rotating cutter. The cutter is mounted on a spindle or arbor and revolves at high speed. Except for rotation, the cutter has no other motion. As the workpiece advances, the cutter teeth remove the metal from the surface of workpiece and the desired shape is produced. Next is the milling method. We have two types of milling method, which is up milling and down milling. So up milling, in the up milling, or we can call it as conventional milling, the metal is removed in form of small chips by a cutter rotating against the direction of travel of workpiece. In this type of milling, the chip thickness is minimum at the start of cut and maximum at end of cut. As a result, the cutting force also varies from 0 to maximum value per tooth movement of milling cutter. So we go for down milling. In this method, metal is removed by cutter rotating in same direction of feet of workpiece. Chip thickness is maximum at start of cut and minimum in the end. In this method, there is less friction involved and consequently less heat is generated on the contact surface of cutter and workpiece. Climb milling can be used advantageously on many kinds of workpiece to increase the number of pieces per sharpening and to produce a better finish. So this the example of up milling process and down milling process. Okay, that's all from me. Thank you very much.
Okay, Assalamualaikum. My name is Muhammad Syahul Nizamin Rosli. I will explain about design analysis. Okay, the design analysis was investigated by Wu and Lee in 2015, which is the nickel-based superalloy Inconel 718 is chosen as their workpiece due to its high strength, resistant to chemical degradation, and resistant to the regulate temperatures. Okay, so we can look at the table below that shows the general properties of nickel-based superalloy Inconel 718, which is values. Okay, basically, density of nickel-based superalloy Inconel 718 is 8.19 gram per cc. Okay, the thermal expansion coefficient is 13 micrometer per meter degree C, and melting temperature is 1336 degrees C. Young modulus is 204 gigapascal, and ultimate tensile strength is 965 megapascal. Okay, so The workpiece, which is a nickel-based superalloy in kernel 718, is drawn by using CATIA V5 software before CNC milling process is started. That's because CATIA software can calculate the coordinate tool position point from the contact point to get the numerical control data in more precise and can be applied in the real experiment. Okay, so the CATIA software simulation parameter has been set by L9 orthogonal array for the CNC milling machine. So the table below shows the optimum values for the uh, CATIA process parameter, which is the cutting velocity has produced 0.718, feed rate produced 0.6918, and the depth of cut produced 0.6119, which means all of these numbers and values is the optimum value for the simulation parameters. Okay, so for the design analysis, we can look at the figure below that shows a few parts and a major part, which is the frame and the spindle and axis and the control panel. Okay, for the frame is the major structural component that support the milling machine and contribute stability and the stiffness. Basically, it has the base and the removable column, and for the spindle, it usually consists of a rotating assembly and tempered part to rotate the tool part of the machine. Okay, for the axis also, it has its own function, which is it can be rotated in three axes, which is x, y, and z axis. Okay, the control panel also has the electronic part, which is can control the various cutting movement through the programming features. So, and this CNC machine can be analyzed by FEM, which is finite element method, to get the optimized of its designs. Okay, so as I told before, this CNC milling machine can be simulated by FEM, which is finite uh, element method, which is this analysis get the agent frequency, which is 10.992 hertz, and based on the figure below that shows the red color is the most displacement part, while the blue color is the least displacement part. Okay, that's all from me. Thank you.
Okay, for the experimental setup or component setup, from the research, we have used nickel-based superalloy in kernel 718 for our experiment. The size of the workpiece used for milling process is 20 mm times 10 mm and 15 mm. The cutting tools with helix shape at angle of 38 degrees and 41 degrees have been used. And for the diameter, 10 mm and 6 mm also used for our experiment. We also have used dynamometer, which is used to know the milling force for X and Y directions. And yes, this is the list of component for our experiment, which is CNC machine, cutter tool, fixture, workpiece, and dynamometer. So that's it for the experimental setup.
Assalamualaikum, my name is Muhammad Fakir Rahman. I want to represent result of experiment. Experimental result of surface roughness for drilling process is shown in table 2. From the result, the minimum of surface roughness is 1.06 micrometer and the maximum is 2.59 micrometer. All raw samples were finished drilling process, except for the sample number 3 due to drill, fracture, and then the surface roughness cannot be measured. This because of the tool was broken. They shown that the combination between spindle speed, feed rate, and drill diameter for sample number 3 of inappropriate. Figure 3A, B, and C show the factor plot the spindle speed, feed rate, and drill diameter toward Surface roughness. However, there are instructions among each of parameter. For the graph, the most significant parameter is spindle speed, followed by drill diameter and feed rate. For one vector plot, the value of surface roughness is decreased when the spindle speed, feed rate and drill diameter increase. Higher spindle speed help remove exit heat rapidly and also eject the chip produced during drilling process. Figure 4A and 4B show the whole observation for example number 1 and 2 repetitively. Sample number 1 show in the figure for low spindle speed and sample number 2 show the high spindle speed. Figure 5 show the sample for number 3. Sample number 3 is the combination of spindle speed at 270 rpm, feed rate 228 mm per minute and drill diameter 2.5. The spindle speed is low and feed rate is high. As a result, the higher feed rate produces excessive chip loading. The excessive chip loading was contribute to the clog and cause the cutting edge to fracture. Therefore, the drill for sample number 3 was broken.
Next, for conclusion, the CNN milling process is critical to achieving a high performance output as it can deliver a high quality surface finish, reduce tool wear, a high rate of production, and a high MRR. All run samples had complete the drilling procedure with the exception of sample number 3, which had a drill fracture and whose surface roughness could not be quantified. Surface roughness is correlated mathematically while taking into account the output corrections of drilling parameters such as feed rate and spindle speed. When only those elements are changed, surface roughness is found to be inversely proportional to spindle speed, feed rate, and drill diameter. Number 3 is the feed rate is fast, but the spindle speed is slow. The clog was caused by excessive chip loading, which fractured the cutting blades. Thank you.